Friends, it gives me great pleasure to welcome you to the 21st Convocation of the Chennai Mathematical Institute. We are very pleased to have Professor Spenta Wadia as the chief guest at our convocation today. So Professor Wadia is the founding director of the International Center for Theoretical Sciences, ICTS, which is a division of the Tata Institute of Fundamental Research. It's in Bangalore. And he is presently the Infosys Foundation Homi Bhabha Chair Professor there. Professor Wadia received his PhD in physics from the City University of New York. Prior to that, he did a master's at IIT Kanpur. Prior to that, he did a BSc at St. Xavier's in Mumbai. And if you're wondering why I'm going back so far, it's because prior to that, he was in St. Mary's School in Mumbai, where I also studied. So, so we share at least a school alumnus. So he is a member of all the 3 National Science Academies. He has received the 1995 ICTP Prize, the 2004 TWAS Prize in Physics, and he has recently been elected to the American Academy of Arts and Sciences. So after his PhD, Professor Wadia joined TIFR in 1982, and he was one of the people who was instrumental in building up the theoretical physics department at TIFR, and especially the string theory group at TIFR. So while he was at TIFR Mumbai, he conceived of ICTS, and he was one of the prime movers in setting up this center in Bangalore, which is quite unique in its conception in terms of the way it promotes programs in science and outreach. And it has had a tremendous impact in its short life. And I would like to say that, in CMI, as I will talk to you a little after this, we have some new initiatives which do draw inspiration from the ICTS. So with this, I welcome Professor Wadia to CMI. So many of you will know some of the things that I'm going to say, but in the interest of completeness, I should talk about CMI in its entirety. So CMI started 35 years ago as a research institution, and little more than 25 years ago, Professor Seshadri's vision of having a very elite teaching program also started. So CMI combines world-class research with high-quality teaching. And as you all know, the students who come here are some of the brightest minds in the country. And traditionally, a large fraction of CMI alumni have gone on to pursue higher studies and go on to academic research and become distinguished academics, scientists, mathematicians, computer scientists in their own right. But somewhat more recently, we have also started a program in data science, and we have now had a track record of graduating some very bright minds who have gone into the industry. So I'm happy to say that CMI currently has an impact both on the academic landscape as well as the industry landscape in India. So CMI, though it is small, has had a very excellent tradition of collaboration with institutions both within and outside the country. So in addition to general projects which individual researchers have had with their collaborators outside, CMI hosts an international research lab in computer science and mathematics along with the CNRS, the French National Center for Scientific Research. And through these connections, CMI regularly has academic visitors and hosts seminars, workshops, and conferences throughout the year. So it has a very, very vibrant atmosphere where students and faculty get to interact with visitors from all over the world who are leaders in their own right. About 3 years ago, CMI announced a new center called the FC Kohli Center of Excellence. And this is the center I mentioned before, which has a vision which is somewhat aligned to that of the ICTS, where Professor Wadia is, where we plan to have a lot of activities, both in existing areas of interest to CMI, but also in newer areas, and have a vibrant visitors program. So this center has been functioning for the last year and a half or so. And we have had, for instance, a quantum semester between January and April, where we hosted 4 workshops on quantum computing. We also have an active partnership with the Banff International Research Station, BIRS, and every year we will be hosting joint workshops with BERS. The first such workshop happened in January this year. There will be 2 more this year, 6 in the following year, and so on. So this will be an annual event where we will have these 1-week, very intensive research workshops with international participants coming from throughout the world. And we are also in talks with the Fields Institute in Toronto to see whether we can pursue some joint activities along with them. In addition, we also have had already individual visitors in mathematics, people like Professor Patrick Polo from Paris, Professor Sandor Kovacs from Washington, who have come and delivered special lectures on various aspects of mathematics as part of the FC Kohli Center. So, along with this new center, another development which has happened in the last couple of years is that we acquired a small additional piece of land, which is not adjacent, but 1 spot away. So the 1 plot away from us, about 10 minutes away. And we are in the process of setting up a new facility there where we will be able to host many such activities. So the foundation is in the process of getting settled, and so hopefully in a year or 2 from now, we will see some activity going on in the new campus. It's about a 10-minute walk from here. So in addition to its very long academic tradition, in the last decade or so, CMI has also made an effort to engage with both industry and government in an effort to contribute to the environment around us. So in 2015, CMI set up a society called Algo Labs to interface with industry. And more recently, we have been talking to the state government, most notably the Tamil Nadu e-governance agency, to find out how we can contribute to what is now called data-driven governance in the local setup. So though CMI is, of course, focused on mathematical sciences, Professor Seshadri was always clear that there should be a component of the humanities. And though we are not big enough to have a separate humanities department, we do have a program called the Arts Initiative, which has been running now for more than 10 years. So through this, we invite artists, musicians, dancers, dramatists to come here. We have some writers in residence. So we have a number of programs that the Arts Initiative hosts to try and bring a wider spectrum of culture to our students and our faculty. So our student population is not very large, but it has had a big impact, especially in terms of the academic ecosystem in India. I've lost count exactly, but I think there are certainly about 50, 60 now CMI alumni who are faculty in leading institutions in India, like TIFR and Indian Institute of Science, the IITs, the ICERs, and so on. And as I mentioned before, in the last 4 or 5 years, we have also placed a number of our alumni in leading industries, both in India and outside India. Our alumni also have won their own share of awards. And just to mention a couple of recent awards, last year, CMI's own PhD student Pranjal Datta was awarded the ACM India Doctoral Dissertation Award for the best computer science thesis in India. And I should also mention that the year before, this award was won by Siddharth Bhandari from TIFR, but Siddharth was also an alumnus of CMI, having done his master's here. And internationally, Anand Shankar, who is one of our well-known alumni, won this Sloan Research Fellowship in 2024 in the US. So one of the other aspects, which is not directly in some sense in CMI's charter, is in reaching out to students at the school level. So CMI has been very active in maths outreach. From the beginning of our teaching program, we have given direct admission to students who have excelled in the Olympiad programs in India. And I'm happy to say that although we have been involved in the informatics, the computing Olympiad, since it started about almost 25 years ago, more recently, we have become more actively involved also in the Maths Olympiad. So we have held the training camp for the Girls Olympiad in 22 and in 23. And we also held this year for the first time the IMO training camp. So this summer we had 60 odd students who competed for being part of the Indian Maths Olympiad team. And as some of you may have heard recently, this year the team had its best ever performance, coming fourth overall with 4 gold medals and 1 silver medal. So I'm happy to say that CMI has been a part of this achievement. And in our new campus, one of the things that we are planning to set up as part of the facilities there is broadly what you might call a maths outreach center, which will have a number of programs, activities designed to, in some sense, publicize and make students at school and college level aware of possibilities in mathematics and hopefully build a culture of mathematics in India. So before I conclude, I would like to thank all the people who help CMI function. CMI, as many of you may know, is a public charitable trust. So we have no formal affiliation to any government organization or any source of regular support, but we do get, of course, regular support from a number of benefactors. From the government, the Department of Atomic Energy through the National Board for Higher Mathematics has been a steady source of support, and they continue to help us year after year. On the private side, the Shriram Group companies have been very generous. In fact, Mr. R. Tyagarajan, who is the founder of this Shriram Group, is one of the people who contributed to setting up this campus, and through his influence, the Shriram Group continues to support CMI every year. We also get support from a number of smaller organizations, not smaller organizations, but smaller amount of support from large organizations, I should say. So the Cognizant Foundation and others also give us some support. In particular, I'd like to thank, as individuals, I'd like to thank, of course, Mr. R. Tyagarajan, who has been the benefactor of CMI for many years now. Mr. Lakshmi Narayan, who's the chair of the CMI Trust and who has been a major source of support and goodwill and getting his contacts to contribute to CMI. We also have with us Mr. Prem Kumar and Mrs. Sujata Prem Kumar, who have graciously donated a large corpus for the activities of the new FC Kohli Center. And there are a number of other such donors. It would be too long to list. But without their support and their confidence, we would not be able to get where we are. And I'm happy that we have been able to create this goodwill among the donors, and I hope that it will continue. So with this, I welcome you all again, and I declare this convocation open. Let the candidates be presented.
Sir, I have great pleasure in presenting to you 21 candidates who have successfully completed the National Undergraduate Program in Mathematics and Computer Science at the Chennai Mathematical Institute in the year 2024 and are eligible to receive the degree of Bachelor of Science Honours in Mathematics and Computer Science. Shruti Sharad Patil, Apratim Ghosh, Ayan Nath, Bijayan Ray, Ishita Ajit Petkar, Madhav C.S., Rajdeep Ghosh, Riddhi Ram Soni, Rishabh Sharma, Rishikesh Srinivasan, Ritabrata Bhattacharya, Rohan Goyal, Romit Roy Chaudhary, Sankalp Sundar, Saptarshi Sadhu Khan, Satya Shrivani B.H., Soham Chatterjee, Soumyadeep Paul, Srijan Chakraborty, Subranil Dev, Swaminathan Rajagopalan.
In my capacity as the director of the Chennai Mathematical Institute, I declare that you are now admitted to the degree of the Bachelor of Science Honors in Mathematics and Computer Science, and in witness thereof, you have been presented the diplomas.
Sir, I have great pleasure in presenting to you 20 candidates who have successfully completed the National Undergraduate Program in Mathematics and Computer Science at the Chennai Mathematical Institute in the year 2024 and are eligible to receive the degree of Bachelor of Science Honors in Mathematics and Computer Science in absentia. Bibashwan Ghosh, Akash Yadav, Abdul Alim Khan, Aditi Mutkod, Ankit Gayan, Aryan Kusre, Avinash Rathore, Ishan Banerjee, Milan Paul, Nilabja Das, Rishav Gupta, Rooptak Mazumdar, Srimadi S.S., Shubh Sharma, Siddhant Devang Shah, Snehanshu Bhaumik, Saugata Panda, Saumir Bakshi, Sufed Salil, and V. Ram Madhav.
So in my capacity as the director of the Chennai Mathematical Institute, I declare that the candidates are now admitted to the degree of Bachelor of Science Honors in Mathematics and Computer Science, and in witness thereof, they have been presented the diplomas in absentia.
Sir, I have great pleasure in presenting to you 4 candidates who have successfully completed the National Undergraduate Program in Mathematics and Physics at the Chennai Mathematical Institute in the year 2024 and are eligible to receive the degree of Bachelor of Science Honors in Mathematics and Physics. Adarsh T. Advik Jagannathan. Anand Balavada. And Naveen Surya V.
In my capacity as the director of the Chennai Mathematical Institute, I declare that you are now admitted to the degree of Bachelor of Science Honours in Mathematics and Physics, and in witness thereof, you have been presented the diplomas.
Sir, I have great pleasure in presenting to you 3 candidates who have successfully completed the National Undergraduate Program at the Chennai Mathematical Institute in the year 2024 and are eligible to receive the degree of Bachelor of Science Honours in Mathematics and Physics in absentia. Sauridi Banerjee, Bhavya Sangam, Shubham Kumar.
In my capacity as the director of the Chennai Mathematical Institute, I declare that the candidates are now admitted to the degree of Bachelor of Science Honours in Mathematics and Physics, and in witness thereof, you have been presented the diploma in absentia.
Sir, I have great pleasure in presenting to you 5 candidates who have successfully completed the National Graduate Program in Mathematics at the Chennai Mathematical Institute in the year 2024 and are eligible to receive the degree of Master of Science in Mathematics. Atharva Sachin Raze, Ujjwal Kiran Das, Sumanta K.S., Advait Hemant Fadnis, Aniruddha Bhattacharji,
In my capacity as the director of the Chennai Mathematical Institute, I declare that you are now admitted to the degree of Master of Science in Mathematics, and in witness thereof, you have been presented the diplomas.
Sir, I have great pleasure in presenting to you. Oh. Sorry about that. Sir, I have great pleasure in presenting to you 1 candidate who has successfully completed the National Graduate Program in Mathematics at the Chennai Mathematical Institute in the year 2024 and is eligible to receive the degree of Master of Science in Mathematics in absentia. Bhavesh Devdatta Padwar.
In my capacity as the director of the Chennai Mathematical Institute, I declare that the candidates are now admitted to the degree of Master of Science in Mathematics, and in witness thereof, they have been presented the diplomas in absentia.
Sir, I have great pleasure in presenting to you 14 candidates who have successfully completed the National Graduate Program at the Chennai Mathematical Institute in Computer Science in the year 2024 and are eligible to receive the degree of Master of Science in Computer Science. Arunava Gantai, Rishi Garg, Shubhankar Vashne, Alan Joseph, Argyadip Chakravarti, Shaurja Basu, Srinidhi T.S., Pradyot Mohanty, Sampat Kumar Kar, Naveen Kumar Sahu, Krishnan D, Parth Iyer, Somnath Bhattacharji, and Sayyid Asla Ahmad Faizi.
In my capacity as the director of the Chennai Mathematical Institute, I declare that you are now admitted to the degree of Master of Science in Computer Science, and in witness thereof, you have been presented the diplomas.
Sir, I have great pleasure in presenting to you 7 candidates who have successfully completed the National Graduate Program at the Chennai Mathematical Institute in Computer Science in the year 2024 and are eligible to receive the degree of Master of Science in Computer Science in absentia. Saptarshi Sahu, Harsh Arora, Satvinder Singh, Siddhant Chaudhary, Bhaskar Pandey, Shri Ganesh S.J., Shashwata Mukherjee.
In my capacity as the director of the Chennai Mathematical Institute, I declare that the candidates are now admitted to the degree of Master of Science in Computer Science, and in witness thereof, they have been presented the diplomas in absentia.
Sir, I have great pleasure in presenting to you 36 candidates who have successfully completed the National Graduate Program at the Chennai Mathematical Institute in Data Science in the year 2024 and are eligible to receive the degree of Master of Science in Data Science. Abhishek Chakravarti, Aniket Saha, Anuraj Kashyap, Anvesha Paul, Arvind Raghavendran, Bhumika Dilip Chawla, D. Shiva Manoj, Deepmalya Datta, Mohammad Jasim, Nidhi, P. Keshavan, Pavan Kumar, Rohan Karthikeyan, Raudranil Das, Shaikat Bera, Samriddha Adhikari, Sanjay Kumar Sinha, Sayantan Mondal, Sayantika Sengupta, Shashi Bhushan Singh, Shreyan Chakravarti, Shubhangi Sanyal, Sneha KK, Soham Sengupta, Sauradeep Das, Subhashri Saha, Sulagna Barat, Swastika Mohapatra, Tanmay Paul, Tyagi Mahir, Ujan Das Gupta, Vaishali Agarwal, Varun Pramod Agrawal, Vinod Mallikarjun Chinsoli, Sarvesh Praveen Bhandari,
In my capacity as the director of the Chennai Mathematical Institute, I declare that you are now admitted to the degree of Master of Science in Data Science, and in witness thereof, you have been presented the diplomas.
Sir, I have great pleasure in presenting to you 11 candidates who have successfully completed the National Graduate Program at the Chennai Mathematical Institute in Data Science in the year 2024 and are eligible to receive the degree of Master of Science in Data Science in absentia. Abhishek Mishra, Abhishek Sharma, Adarsha Mandal, Akash Das, Anjan Mondal, Anna Maria KV, Anurag De, Anusha R, Mohit Kumar Jain, Shreyam Banerjee, Thorve Akash Dada.
In my capacity as the director of the Chennai Mathematical Institute, I declare that the candidates are now admitted to the degree of Master of Science in Data Science, and in witness thereof, they have been presented the diplomas in absentia.
Sir, I have great pleasure in presenting to you one candidate who has successfully completed the degree of Doctor of Philosophy in Physics at the Chennai Mathematical Institute in the year 2024 and is eligible to receive the degree of Doctor of Philosophy in Physics. Shanmuga Priya P.
One second, I'll read it out and then she can. In my capacity as the director of the Chennai Mathematical Institute, I declare that you are now admitted to the degree of Doctor of Philosophy in Physics, and in witness thereof, you have been presented the diploma.
Sir, I have great pleasure in presenting to you one candidate who has successfully completed the degree of Doctor of Philosophy in Physics at the Chennai Mathematical Institute in the year 2024 and is eligible to receive the degree of Doctor of Philosophy in Physics in absentia. Sayantani Datta.
In my capacity as the director of the Chennai Mathematical Institute, I declare that the candidate is now admitted to the degree of Doctor of Philosophy in Physics, and witness thereof, he has been presented the diploma in absentia.
Sir, I have great pleasure in presenting to you two candidates who have successfully completed the degree of Doctor of Philosophy in Mathematics at the Chennai Mathematical Institute in the year 2024 and are eligible to receive the degree of Doctor of Philosophy in Mathematics in absentia. Jagdish Pine. Malay Mandal.
In my capacity as the director of the Chennai Mathematical Institute, I declare that the candidate is now admitted to the degree of Doctor of Philosophy in Mathematics, and in witness thereof, they have been presented the diplomas in absentia. So we now come to the segment where we have some special awards. So we have traditionally had CMI Gold Medals of Excellence for the top performers in the various disciplines in which students have received awards in bachelor's and master's today. So there are 5 such awards for BSc Mathematics and Computer Science, BSc Honors Mathematics and Physics, MSc Mathematics, MSc Computer Science, and MSc in Data Science. So these were initially instituted by Professor K.R. Nagarajan, who was one of the people who initially helped set up the teaching program. And over time, the funding for the awards has been expanded. So we get now some support from Bajaj Alliance and from Professor Gauri Vishwanathan. In addition to these, we also have some more specialized awards which were initiated recently. So we have from one of our trustees, Mr. Arun Dugal, has instituted an award for the best outgoing female student in bachelor's and master's in mathematics. So we will be presenting those awards. And we also this year have instituted an award by Mr. Jeevan Kapoor, which will be awarded for the best outgoing female student in data science. So I call upon KV to announce, and Spenta, I think.
The Arun Dugal Award winner is Ishita Ajit Petkar. Mrs. Chandar Mohini Kapoor and Mr. Jeevan Kapoor Merit Award, instituted by Shri Jeevan Kapoor, goes to Bhumika Dilip Chawla. The CMI Gold Medal of Excellence in BSc Honors Mathematics and Computer Science goes to Ayan Nath. The CMI Gold Medal of Excellence in BSc Honors in Mathematics and Physics goes to Advik Jagannathan. The CMI Gold Medal of Excellence in MSc in Mathematics goes to Atharva Sachin Raje. Oh. The CMI Gold Medal of Excellence in MSc in Computer Science goes to Nabeen Kumar Sahu. The CMI Gold Medal of Excellence in MSc in Data Science goes to Rohan Karthikeyan.
So with that, we come to the end of the segment of handing out certificates, medals, and awards. I now request our chief guest, Professor Spenta Wadia, to deliver the convocation address.
Good afternoon, and thank you for inviting me. And I'm very happy to be here in front of all of you students and colleagues and my some senior, very old colleagues also. Okay, so I think just a minute. Okay. Can you hear me? Okay, so I had asked Madhavan what I should say because I didn't think I was so much qualified to give a lot of advice to people. So I'm not going to do that except at the very end. And I just wanted to first of all congratulate all of you for your achievement. And I wish you all the best for your future endeavors. So with that, let me just begin my talk. So this is a talk which is somehow a mixture of history, of the importance of technology, basic sciences, and various other things. Okay, so bear with me. So I'm going to talk to you about the history of time. Now, I hesitated a lot to talk about this, to mention this title, because, you know, there's a very famous book called A Brief History of Time, but that's okay. Apologies to Stephen Hawking. So I just wanted to talk to you a little bit about how, as a species, as humans, we started thinking about time. And I'm not a historian, but I think this is more or less correct. So awareness of day and night is obvious as the sun appears and disappears daily. And this is related to the spinning of the earth on its axis, an explanation that came, of course, much later. You see. So day and night are wired, of course, into our genes. There is secretion of melatonin in the evening that induces sleep, and such circadian rhythms are present in animals, plants, and other living matter. And so here is a simple diagram of our Earth with a very, very, very important tilting angle of 23.4. Let me tell you, if it was even slightly different, there will be very major consequences. Okay. So the second way in which human beings started being aware of time is the issue of night and day is one thing, but then the issue of the year is there. So awareness of the duration of the year during the early history of our species is through the seasons and their manifestation in terms of hot and cold weather, the appearance of fruits and flowers, migratory patterns of birds and animals. And when agriculture came about, a time of sowing seeds and a time for harvest. So all of this I've just illustrated by pictures which all of you know very well from your studies. And this is the, the elliptical orbit of the Earth around the sun. Let me go quite fast to the main point I want to make slowly. Then there is the issue of the waxing and waning of the phases of the moon and the rise and ebb of tides. Now, the amazing thing is that the present day, the moon's rotation around the Earth synchronizes with its motion around its axis. That is why you never see the other side of the moon, actually, okay? Okay, so this became some sort of a natural timekeeper. There's lots of mythology, lots of stories, lots of worship of this amazing satellite of Earth, which also, as I'm going on, I'll tell you some physics also, stabilizes the axis of the Earth, actually, you see. Without the moon or with a slightly different mass, this will be a very wobbly axis, okay. Amazing amount of coincidences has made it possible for us all to be here. Okay, it's incredible, actually. So, early in history, it was our sensory perception of the motion of Earth in the solar system and the visible periodicity of the phases of the moon, that enabled us to have a notion of time. And it grew out of the almost periodic cycles of the natural world. and the fact has continued into the modern world. I think the most important word in this sentence is almost. It's not exactly periodic. And it's a very big subject about the periodicity of the solar system in mathematics also. Let me just move on. I don't want to get stuck on things here. I have only half an hour left, I think, something like that, right? Okay, so now more sophisticated timekeeping devices emerged based on astronomy. One imperative came from navigation at sea, you see. As the seasons change, the movement of constellations as a group of stars, which have very nice names in all mythologies, is visible in the night sky. This is due to the orbit of the Earth around the sun, okay? The synchronization of celestial and terrestrial changes naturally suggests a causal relationship between them, and so observing the motion of constellations and planets became a way of explaining and predicting events on Earth. So this is the foundation of astrology, you see, in some sense. It's amazing. And there's a very beautiful book which I recommend very strongly to all of you by James Vincent, from which I have learned a lot, actually, trying to prepare this talk. All right, so this is a very important point. So, however, celestial timekeeping has inaccuracies built into it because celestial motions, as I said, are never perfectly periodic. They are not perfectly periodic because, you see, the motion of the Earth around the sun is almost periodic. But, and it's almost periodic because of all the other fellows around, actually. There are other planets, so these perturbations, thankfully, they just don't destroy the orbit completely, actually, okay? So, for example, the length of the year measured between equinoxes is something like this, 0.2422, but over centuries, let's say 500 years, this amounts to 121 days, okay? And similarly, the average length of a lunar month is 29 days, 12 hours, 44 minutes, 2.8 seconds. So the variation is about half a day. And the reason for that is because the moon is going around the Earth, but the Earth is going around the sun. Now, I leave it for you to compute why this happens, okay? All right. All right, so this is the end of the first part of the talk, where it is celestial happenings that have organized time, okay? And its social impact is enormous. It's even there today. Terrestrial timekeeping devices. Now, society has also developed various terrestrial timekeeping devices. For example, the water clock, which everybody knows about. Just some pictures here, of course, the sundial. Then this is the sand glass. And this is a even more, very interesting one, the incense clock. The time was measured by means of powdered incense burnt along a pre-measured path. Fascinating stuff. So these devices are not very accurate timekeepers, but they are terrestrial devices, something you can make on Earth. For example, the water clock's measure of time depends upon the temperature of water, obviously. So, all right, so this is the history of technology for timekeeping, very, very ancient. But now comes a very important and very big breakthrough, actually, in history, in the history of technology, in the history of science, I think. And that is the discovery of the oscillator and escapement mechanism that creates the regular periodic beat of timekeeping. And that was originally developed in countries like China and the Middle East. Please note this. Towards the end of the 13th century, European craftsmen refined this mechanism to create the first mechanical escapement mechanism that led to the mechanical clock. And you will, if you're sort of old enough like me, and we traveled a lot, you must have seen that in every big European town or even small towns, there's always a clock. It is so, I mean, in London also there is a clock tower. I mean, even in the city of Mumbai, there is a Victoria Terminus railway station has a clock, right? Okay, now, what's happening? So, the mechanical clock propelled a new conception of time into the public consciousness, transforming it from a constant flow embodied in steady emissions of water, sand, and mercury to a quantified count. Divisible, discrete, and measurable. As with monastic bells, public clocks organize citizens into a cohesive unit, turning what had previously been private lives into communal tides that rose, worked, and retired as one. So the clock is not merely a means of keeping track of the hours, but of synchronizing the lives of men. I think this is a very big change, and we are approaching the time when the scientific method is born. So all this is from this very beautiful book. So the pendulum clock was designed by Galileo, and it was the first working model was invented by Huygens, and was constructed by this craftsman Solomon Coster in 1656. So you know about all this. I don't want to get into it. Okay. So now this is a very important slide. And in a sense, in a very deep sense, this is what I wanted to really get to in the first part of the talk. The clock, which is a machine, became a symbol of a new way of conceiving the universe. That's mechanical philosophy. The mechanical philosophers reasoned that if clockwork was able to capture the movement of the stars and bring an elaborate automata to life, who was to say that the natural world did not operate under a similar logic? If nature worked like a machine, then it must rely on observable cause and effect. So Galileo Galilei, more than any one of his contemporaries, crystallized the integration of experiment and theory and laid the foundation of the scientific method. He died in 1642, the year his successor, Isaac Newton, was born. So this is the end of the first part from our perceiving time in terms of our senses, all the way to the discovery of the mechanical clock and its impact on the scientific method. Okay. All right. So, of course, at the back of all this, you must not forget that the mathematics and mathematical thinking, measure, and all that is also very important. But I can't go into all that very interesting stuff now. Okay, so now let me begin with the second part. Okay, this is just to remind you that even today we try to define time very accurately, but in terms of new laws. You know, whenever you have a law, a new law, that is the law of quantum mechanics, then we are able to devise devices which work on this new mechanics. It'll be 100 years old next year. 2025 is the 100th anniversary of quantum mechanics. And this is the quartz crystal, which everybody talks about, and I don't want to explain this mechanism, but please look it up, it's very good. And this is the most important one, actually, that it's the, so if you look at the ground state of the cesium atom and look at its hyperfine structure, which is highly non-classical, then the emission of radiation, that frequency is used to calibrate the most accurate clock we know on Earth today, and that is from this cesium atom. I just wanted to put this in because it just went right from Galileo onto the early part of the 20th century to tell you that the keeping of time has a lot to do with the type of laws that you have sort of mastered, okay? All right. So I don't think I'll talk of quantum mechanics at all in this talk now, but I just thought I should say this. All right. Now I turn to something else. So I want to, this is all about time. You will notice that. So we briefly talk about Newtonian framework of physics, universal time, and the law of gravitation. And you might be wondering why I'm talking about the law of gravitation. Because as I'll mention to you, and you all know most probably, that time flows more slowly at the surface of the Earth than very far away from it, like the satellites that control your GPS. So gravity has a very deep connection with time. That's why I want to mention something about Newtonian gravity also. Okay, very quickly, everybody knows this, but just the important point that Newton establishes a framework of mechanics. The main point is that all natural processes, this is an abstraction, this is math really, okay, take place in space and time. And so he formulated the laws of motion as a flow in time of the position of a point particle in 3 dimensions. You all know that. I'm not going to say anything more, except that the important point here is that time is absolute and same for all observers. Your time, my time, the time in Mumbai, time everywhere. All our clocks are synchronized. That was one of the cornerstones of the mechanics of Isaac Newton, okay? So this is a very important point because this gets violated in the early part of the 20th century. Okay, so this is the universal law of gravitation. And in terms of this, leads to the famous elliptical orbits of the planets described by Kepler. And let me tell you one thing, that the first person to discover symmetry in big data is Kepler. That's what he did. He had all this data from astronomy, from Tycho Brahe and other astronomers. What did he do? He found a symmetry in that data, so he changed the coordinate system to the sun, and everything fell into place. So I think he's one of the first data scientists, actually. Okay, let's go on. So this is some quotes from the Principia Mathematica of and this is the important one, that Newton never felt comfortable with his law of gravitation because it had this idea of instantaneous interaction. Means if you move here, this will instantaneously move, okay? So that's an important point, but he never, it's a great tribute to him that he felt that something is wrong about this. And I feign no hypothesis. Okay. All right. Next chapter. So we are still talking about time, the fact that time, all clocks are synchronized for all observers, whichever way they are moving, okay? Now, that basic idea is overthrown by the discovery of Maxwell's equations of electromagnetism. So every time I'm telling you something about physics and how it affects our notion of time, okay? So that's the way I have planned it. Okay, so this it's one of the great synthesis of knowledge that Maxwell unified electricity and magnetism, predicted electromagnetic waves, identified them with light. Okay. Now, all right. So then later on, people discovered other forms of the electromagnetic wave, namely X-rays and and microwaves. And this slide is just to impress upon you the fact that experiment is extremely important in science, actually. That you have experiments that give rise to theory, then theory to new experiments, etc. It just goes on. Okay, so Maxwell's equations, this is the essence of Maxwell's equation that was distilled by Einstein. And it's the following, it's very simple. That if you have a flashlight somewhere, and if you run towards it or away from it, the speed of light will not change. So this is the central principle of the theory of special relativity that comes from electromagnetism. Okay? Electromagnetism is an experimentally verified theory, so this must be true. And therefore, there is a radical change. And this is what Einstein realized actually, that there's a radical change in our notion of time, that time is relative. It depends upon the way you're moving with respect to each other. So it's a very simple, very elementary calculation will give you this very simple law that so if you have a spaceship and if you have this observer, just stationary somewhere, and this is how the light looks like. You have two laser beams going up and down, up and down. But to this observer, the laser beam travels like this. And because the velocity of light is constant and invariant in both frames, you get this very famous time contraction law. So, intervals of time depend upon the state of motion. So that is the first important thing of Newtonian physics that goes down, okay? A new conception of time arises. Okay, so we are now in 1905 approximately. Okay? All right, and now there comes a very important mathematician, Hermann Minkowski. He was Einstein's teacher, and he geometrized this idea of space and time, okay? It's a very big step actually. And as Minkowski said, space by itself and time by itself are doomed to fade away into mere shadows, and only a kind of union of the two will preserve an independent reality. So he did define, just like in Euclidean geometry, you have the notion of the metric, the flat space, ds square is equal to dx4 square plus dx square. So there's a minus sign over here. This is it's called a Minkowski spacetime. Now the importance of this is that this formed the basis of the next big step about our history of time. And it's the following. Okay. So given that the speed of light is the same for observers in relative motion, there can be no action at a distance, you see, obviously. So there goes Newton's law of universal gravitation, because the speed of light is constant for all observers. And I invite you to read the history of the discovery of general relativity. It's very, what shall I say, it's very encouraging that, normal people like us can also do some interesting work, because this man made so many mistakes in arriving at the final law. It was an enormous struggle actually to arrive at the equations of general relativity. So Einstein made many, many mistakes actually, and I don't have the time to recount all of that. But he put forth this theory in 1915, and it's a theory of gravity in which the force of gravity is not instantaneous. It is communicated at finite speed by changes in the geometry of space-time, okay? I have a little picture about that. Hence, the role of the electromagnetic field is played by the waves of metric of space-time. All right. So, just some cartoons over here that, as I said, GR describes changes in the geometry. But you might be wondering that why I don't see these changes in my daily life, or even in over all the years. Why is it that you don't see that if I move my hand, the space-time is wobbling? Why? I'm not producing any gravitational waves doing that. It's because because space-time, imagine like an elastic medium is very, very stiff, 10 to the 20 times stiffer than stainless steel. So you're not going to get gravitational waves by shaking your hands, or even if two Earths collide. You needed a cataclysmic collision of black holes to produce these gravitational waves, which were observed in 2015. That is the famous discovery of LIGO. Okay, so this is just a cartoon trying to show you Einstein's picture of the orbits of the planets. Okay, it's that geometry, the sun changes the geometry, and the Earth moves in a geodesic around this geometry. Okay, all right. Now, time. This is very, very. So these cartoons are these things are all done by my good friend Juan Maldacena. I have his permission forever to use them in popular talks. So let's see what happens. So time flows more slowly, 1 part in 10 to the 15 for a height of 100 meters. This is the effect that you have to take into account for an accurate GPS, which you all are using all the time, right? This is the reason why you have to take into account general relativistic corrections in order to be able to say where you are when you look at your phone accurately, okay? So a very abstract theory like general relativity also has applications which all of you are enjoying, okay? So another picture of this, that if you have a very big star, for example, and you're very, very, very far away from it, then time goes much faster for you than when you're closer to the star, okay? And when the star becomes a black hole, for example, time just stops at the horizon of the black hole. Okay? And I just wanted to impress upon you that a lot of the story of gravity and general relativity has a lot to do with our understanding of time. I won't go any further in this now, but I just wanted you to appreciate that if you are very near a gravitating object, time slows down. And at the horizon of a black hole, for example, it just stops from the viewpoint of this observer. Okay? All right. So I have more or less come to the end of my talk, and just before I finish, I wanted to tell you one more very important thing, that up till now we have been discussing about the measurement of time in terms of regularities observed in nature, okay? From the understanding of, or from the perception of day and night to the perception of the year, the seasons, the constellations, the mechanical clock, Newtonian physics, and its modification by Einstein, and general relativity, all that we have done now. I am not going to talk about quantum mechanics and its impact on our understanding of time, because that's another chapter. But I just wanted to leave you with a couple of things here. Okay, so, but most phenomena in the real world exhibit fundamental irreversibility. They consider burning of a piece of wood. Final state is simply ash and carbon dioxide and gases. One never observes this final state assembling back into the piece of wood, right? It's amazing, right? That's some arrow of time that we all also feel and perceive. And so people worked a lot to quantify this idea. And it was finally, I think, done in a monumental piece of work by Ludwig Boltzmann in 1866, who introduced a formula for the entropy of a gas as a measure of the number of internal states that make up the system, and showed under reasonable hypotheses about the randomness of collisions that the entropy always increases in time. Like the entropy of the gas in this room, the air in this room, always increases in time is because of the random collisions, and Boltzmann made this very deep connection. And subsequently, after laying the foundations of statistical physics, this was formalized at a very deep level by John von Neumann in 1932. So this is the von Neumann entropy, which is a very important measure in modern quantum mechanics. And it is also used by Claude Shannon, these ideas, to formulate the modern theory of information and communications. So with this, I think my formal talk is sort of over, and I have a little picture for you. This is about the flow of time. We know very little about this stuff here, very little. We know our observations start from here, you know, around 300,000 years after the so-called beginning of our universe. These words are very inaccurate. We have no idea what this beginning was, but we have to just say something, right? This is a lot of extrapolation over here. There's an amazing amount of physics that and astronomy, astrophysics, math, everything that goes into giving you this type of a cartoon picture of the universe. And here we are, somewhere there. You see, the universe has cooled down a lot. I mean, from this temperatures, which were very, very high. So there we are. And, I wondered about this. So I want to, 2 slides I want to talk to you about. So, this is a quote adapted by me from a book, The Universe is a Green Dragon. Let me read it out. The most amazing is this realization that everything that exists in the universe came from a common origin. Okay, the material of your body and the material of my body are intrinsically related because they emerged from and are caught up in a single energetic event. We were all belched in the stars, and the stars all came from the early universe. And all this is new. None of the great figures of human history were aware of this. He had a few names here which I removed. I don't want any controversies. We are the first generation to live with an empirical view of the origin of the universe, and we are the first humans to look into the night sky with, of course, our telescopes, our very sophisticated telescopes, and see the birth of stars, the birth of galaxies, the birth of the cosmos as a whole. And our future as a species will be forged with this new story of the world. Now, okay. So, why did I give you this talk, actually? It is because of this last slide. In a sense, I wanted to say something to you, but put it in a context, actually. And this is my last slide. So here we are, all of us, 13.7 billion years in this vast, cooled down universe. Cool means, 2.7 degrees Kelvin is the ambient temperature of the universe. On a small rock called the Earth, which is about 4 billion years old and sailing through the universe as part of our galaxy, which has 100,000, not 100,000, 100 billion stars. And we are part of the galaxy of the Milky Way, which is one of the 100 billion other galaxies and this is all of the observed universe, okay? Now, this immensity and complexity must make us feel humble. And this is the key point I wanted to make to the students, actually. That, in our daily life, in our interactions with colleagues and all, we have to step back and think about this point, actually. So I just wanted to communicate this to you. And there is much to be said today about the perturbation in a very technical sense of the state of the Earth, by us humans, and about the preservation, and about the preservation of our species and others that we coexist with. This is this whole issue that where is planet Earth going? It's going to its doom or what? And we've got to do something about that. Now, how? So one of the most important developments of the last millennium, in my view, is the development of the scientific method as a means to access the idea of truth. The idea of truth is quite central, actually. If you look at politics, if you look at newspapers, if you look at daily life, the idea of truth. I mean, what is the truth really? Is a very central question, actually. And how to get to it, in my view, is by this method which has been sort of developed over the last millennium, more so over the last 500 years. And hopefully you will imbibe this and see the world in all its aspects, not only when you do science, but your society, your history, your relationships, whatever, environment, and our survival as a planet through this lens of the scientific method. So thank you very much. Yeah. I think I was on time. It's amazing. So I hope there are no tough questions. Huh?
Open for questions if anybody.
I was not prepared for that one. Okay, never mind. You have a question, please ask. All right. Take it out.
I have to say that. So thank you so much for a wonderful talk. And with this, I dissolve the convocation. Please join us outside for some tea and refreshments.
Passing out batches, please wait for photos, batch-wise. Thank you. BSc Maths and CS, please come on stage.
இந்த கூடியமா இல்லை எஸ் நான் கூப்பிட்றேன் இது ரெண்டு வயர் மட்டும் பார்த்து
Spaces don't have to. Atharva. MSc Computer Science. MSc Computer Science. So I just wanted to tell you that it's real good. Yeah. So just remember it. Yeah. Most of the time it is played. This is your pen.
MSc Data Science.